So, Sri Akal students, so we have next lecture on sets, class 11th. This is a record of previous videos on set. In order to have good grip, you should listen to all with your notes. Let's discuss what is union of sets. So, students, you see that let A and B be two sets. Let A is equal to 1, 2, 3, 4. It has 4 elements. Let B has just 2 elements, 3 and 7. The union of sets, students, is the set. Union of sets, it's a set which consists of all the elements of A, all these 4 elements of A and all the elements of B. That means all the elements of B. Now, then the total elements become 4 plus 2, 6. But then we see 3 is common in both. So we will take 3 only once. The common elements being taken only once. So this union of sets, students, is represented by U, A union B is equal to a set which has all the elements of A. So let me write down all the elements of A. Then I will see whether any element is there in B. 3 is there. I need not write. I'll take 7. So in a way, I've taken both the elements of B and all the 4 elements of A also. This is union of sets. Symbolically, we are writing like this. This is a symbol we use to represent union of sets. In order to get the physical meaning of union of sets, students, let X is equal to 3 students, Ram, Geeta and Akbar. Now, let Y be a set having Geeta, David, and let's say Rajendra Singh. All right. Now, when I want to divide union of 2 sets, I'll write X union Y. Students, this is equal to how I used to do. I'll first write all the elements of X, Ram, Geeta, Akbar. Then I will write, I'll see if any member is getting repeated here, Geeta. I'll not write David and Rajendra Singh. So students, if I say X union Y, what is the physical meaning of this? These are 3 students in set X and 3 students in set Y. X union Y contains all the students which I can say which belong to X, which also belong to Y, as well as which belong to both. This is something very interesting, right? And this is the definition also we are just going to discuss. Now, how I represent this. Now, I'm going to talk about this definition. And what is this definition? Whatever I've learned just now, just this definition actually tells me what is the meaning of union of 2 sets. Let me read it. See, the union of 2 sets A and B is the set C, which can be written as C is equal to A union B, which consists of all those elements which are either in A or in B, and including those which are in both. So this is the physical meaning of A union B. Interestingly, students, one more thing to note down. Let's say A is equal to 1, 2, 3, 4, right? Let's say B is a subset of A having two elements 2 and 3. See, what is A union B? A union B is, I'll write all the 4 elements of A, 1, 2, 3, 4. I'll see if any element is getting repeated in B. 2 is getting repeated, I won't write. 3 is getting repeated, I won't write. So you see that A union B is equal to set A. Now, what is the relation between A and B? Students, are you able to point out? Can you tell in 1 second? What is the relation between set A and set B? See, we've already studied, students. Interestingly, in this case, B is a subset of A. So we have this observation. If B is a subset of A, then A union B, or you can say B union A, it's one and same thing, is equal to the bigger set, or you say the superset. See, A and B are not equal in this case. So A union B is actually the bigger set or the superset A, as we got in this case. Am I right? Now, what if A and B are equal, students? If A is equal to B, let's see this case also. Let's say A is equal to 1, 2, 3. B is equal to 2, 3, 1. Right? Now, in this case, students, what is A union B? All right, write down all the elements of A. 1, 2, 3. See if any of the elements is getting repeated. All are getting repeated. Don't write any element. So A union B is equal to A is also equal to B. All right. So if two sets are equal, we can say A union B, or which is equal to B union A is equal to A, which is equal to B. All right. Guys, on Venn diagram, how can I represent A union B? This is my Venn diagram. All right. On this, student, I have a concept of universal set here. All right. Now let's say this is set A, right? And I have another set B, and they have some elements common. So common elements I don't want to repeat. So if students, interestingly, you see, if I write like this, that means these common elements of A and some common elements are getting repeated, but I do not do like this. If there are some elements common, I will take them like this. This is exact representation of A union B. I can give an example also. Let's say A is this set, B is this set. Let's say A is 1, 2, 3, and B size looking bigger. Obviously, I'll draw a little bigger set. 2, 3, 7, 10. See, 2 is common. So A is in this circle of A, I'll get 2, 1, and 3. Am I right? And in B, I get 2 is common. 3, 7, 10. Right? Now you see, in this beautiful way, 2 is not getting repeated. So A union B has 5 elements, 1, 2, 3, 4, 5, 6 elements, right? So this is a representation of the A union, how will I write A union B, students, in set builder form? So guys, A union B would be is equal to set of all x or y or z such that x belongs to A. Students, this is very important, so I will write with red ink. Or, very important, and this importance will be understood when we do intersection. X belongs to A or X belongs to B, or either it belongs to A, either it belongs to B. In this way, we will avoid the repetition and also include the common element. This is the definition of A union B and representation in set builder form. Now guys, we are going to discuss some properties. See, we are going to discuss some properties of operation of union. So we're going to prove them side by side, and we're going to learn also what is the properties of union. So guys, the first one, see here, first property, A union B, I've already mentioned also, is equal to B union A. It's like we say in commutative law, A plus 1 plus 2 is equal to 2 plus 1. So it's similar to this, is commutative. So I'll write this as commutative, right? Commu, this is commutative law. The X union of A and B sets follows commutative law. How can I give an example of this, students? I can give an example of this. Let's say A is equal to 1, 2, right? Let's say B is equal to 7. So what will be A union B? This will be equal to 1 to 7, and this will be equal to B union A. Write down elements of B. 7. C is getting, whether any element of B is getting repeated in A? No, 1 to include 1 to also. Right. Now guys, I talk about the second property of union of sets. All right. So second property is, students, is like A union B union C is equal to A union B union C. What is the meaning of this? Again, let's discuss. All right. So let's say in this case, same A and B is this. So what is first? First I'll see what is B union C. So what is B union C, students? This is equal to, all right, I have to define another set. Let's say student set C is 10 and 3. All right, A is this, B is this, C is 10, 3. So let us try to define B union C. B union C would be, write the elements of B. 7. See if any element is getting repeated in C. No. Write down all elements of C. 10, 3. Now this is B union C. Then what is A union B union C? Means this take as one set. A union B would be equal to, write down elements of A first. 1, 2. See if these elements are getting repeated in B union C. No. Write down all the elements. 7, 10, 3. Now student, if you find A union B, see A union B is, no element is getting repeated. 1, 2, 7. Now A union B, union C. Union C would be equal to, take the elements, other elements also, 10 and 3. So which is equal to this. Hence proved this property, students, is associative law. Associative. So union follows associative law also. Oh, that's great. So what is the third law? Third law is very simple. A union phi, null set. A union phi. Let's understand. Let's say A is same. 1, 2. What is phi? Phi is a null set. No element. So what will be A union phi? Write down elements of A. Elements of A are 1, 2. What is the element of, any element of A is getting repeated in B? No. There's no element in phi also. So this 1, 2 is equal to A, right? So A union phi is equal to A. This is law of identity element. Law of identity element, right? You can say phi is the identity of union. Phi is the identity of union. For example, phi, suppose you see like 7 multiplied by identity 1 is equal to 7. No change in 7 in multiplication. So in union also 5 behaves what 1 is behaving, getting multiplied by 7. All right, students. Now comes fourth law. So what is fourth law, students? What about A union A? Well, this is A. What will be A union A? All right, I'll write all the elements of A, 1, 2, and then I'll see if any element is getting repeated in A, both are getting repeated. All right. So this is equal to A. A union A is equal to A. B union B is equal to B. Okay, this is known as which law? Idempotent law. Idempotent law. And the last one, students, if I talk about universal set, it's a big set, very big set, infinitely big set sometimes. Universal set, union A. So all the elements of A will get merged in universal set. Ultimately, you will get universal set. Well, this is, students, law of U. All right. Here I sum all the properties of operation of sets. It's better you take different sets, your own sets, change numbers, 2 numbers, 3 numbers, 4 numbers, and then prove all the properties yourself. That goes to your brain, remember, for a longer time. All right, students. Having done this, students, now we proceed towards intersection of sets. What is intersection of sets? Intersection of sets. So guys, intersection of sets, first I will talk about generally what is intersection of sets. So guys, intersection of sets is the intersection of sets A and B is the set of all elements which are common to both A and B. Student, A word is very, very important in this intersection of sets, whereas R word is important in union of sets. All right. And interestingly, when you use and, the number of elements increase, but here using and, the number of elements will decrease, and relates to common. It's like something belongs to this house, and the same thing belongs to this house also. So one house has so many things, other house has so many things, but I'm talking about only those things which are available in this house, and means as well as other house. So that means and is decreasing the number of elements. So guys, intersection of sets is represented as A intersection B. So intersection of two sets A and B is a set of all elements which are common to both A and B, is equal to set of all x such that x belongs to A. I will not use R. Increasing number of elements, I will use R, and let me increase the width size and the color also. I will write and here. Right, students? And what? And x belongs to B. This is what I told you before in the last slide. When I define A union B, it's a set of all x such that x belongs to A or x belongs to B. I'm increasing the chances, the probability of chances of having more elements. X belongs to A, 1, 3, or x belongs to this, 3, 7, 10 also, plus x belongs to all those elements which are common to this. So I'm having so many numbers. But if I say like intersection, let's say I write intersection here, A intersection B is C set of all x such that x belongs to A, and here and means as well as, it's important, x belongs to A as well as x belongs to B. What does that mean? So what will be the set? Students, 1 second. Students, can you tell me what will be A intersection B? Any student? All the numbers which belong to A as well as which belongs to B also. So they are obviously the common numbers. So what is common between A and B? Come on, students.
2 and 3.
2 and 3. Oh, 2 and 3. Very good. Then Ishma, I have drawn this wrong. I'm so sorry. It's good we have taken this. Then this 3 should also have been here. Okay, it's really great. God helped us. 3 shouldn't have been here. Am I right? 3 should have been here because otherwise 3 is getting repeated. So I said wrong. I'm so sorry, students. The A union B will not have 1, 2, 3, 4, 5, 6 elements. Rather, it will have 1, 2, 3, 4, 5 elements. Okay? I request you humbly, students, to correct the mistake. You know, to err is human. Thank you, Ishma. 2 should have been here. But here, anyway, when I say X, A intersection B, A intersection B, B means A which belongs to A also, and also, not or. Or, अरे यार क्या करोगे जिंदगी में? What will you become? Yeah, I'll become a doctor, or I'll become an engineer. Is not motivated. Or I will become maybe optician, or yeah, or I may become, you know, I may become a businessman. So he may not become anything, but then he's, you know, he may become this or this or this or this, you know. So somebody says, example of intersection. He says, listen, I want to, you know, I want to become a eye specialist at the same time, and I also want to have a showroom tomorrow selling spectacles. Is limiting the numbers, and so both are getting together, both are linked. he becoming an optician, at the same time having a showroom, having spectacles. He would be checking the eyes of the person also, right? Intersection limits the number. Union increases the number. So union is given by the word or, right? So guys, let's go further. Uh, A intersection B already defined. Now we are going to discuss some properties of union, but we are not going to prove in this lecture. In the next lecture, watch out guys, we are going to prove all the properties of operation of union. So I'm going to write here what some properties of operation of union. Some properties of union. So what are the properties? Which are the laws it follows? Very important base so that you can do difficult questions tomorrow easily. So guys, first one. Does it follow commutative law? Yes, it follows commutative law. I'm sorry. Does it follow commutative law? All right. So, oh, I'm sorry. I've written union here. Some properties of operation, not of union. Sorry, students, but of intersection. All right. Okay. So, students, sometimes you feel confused and you might feel, oh man, that's a bad quality. But if you remember Einstein saying, intelligent people I find confused most of the time, full of doubts, and stupid people I find most of them full of confidence. You don't worry, feel confused. It's okay. Maybe a sign of intellect. Don't be more confused. Some properties of operation of intersection. So let's see. Does it follow commutative law? Yes, it follows commutative law, just like union. A intersection B is equal to B intersection A. Well, it only suggests that here I'm getting elements which are common to A and B. This also is suggesting the same thing. So it follows the commutative law. Second is A intersection B. You get one set common of this, and then students, intersection with C would be equal to A intersection of B and C, right? We can prove it also, but we'll do it tomorrow. Okay. And the third one, phi intersection A. Can you say this will be equal to common elements between phi, no element, here so many elements. So this will be equal to, yes students?
A.
No, I cannot take elements of A because those elements are not there in phi. I cannot take elements of A. The elements of A may be 5, 1, 2, 3, 4, 5, but they are not in phi. Phi means null set. I have to take common elements which are in phi, means no element, as well as A. So no element is also there in A. No element is also there in phi set. So I'm going to talk about a set which has no element, that is phi. Okay, you got confused with union. Union of phi and A is A, right? Okay, guys. So, and then comes, what about universal set? And intersection with A would be equal to intersection always limits. It's like किसी के पर काट देने. Union add कर देने. It's like integration. So can you tell me, Ishma? Intersection of union and A would be, see, maybe 5 elements in A, maybe 1,000 elements in U. And those 1,005 elements, let's say, of A are also in U. So this will be equal to U.
A.
Yes, 100% right. You have a background built in your mind and then you understand very well. So Ishma, maybe we understand less, we have less lectures, but it should be crystal clear. Okay? Please bear with us. This is law of phi and U. This is law of phi null set, and U universal set, which has been also declared invalid by a few mathematicians. Okay, so and then we gonna go for A intersection A. Yes, students, A intersection A, that A has elements 1, 2, 3. So A intersection A, other set A is also same set 1, 2, 3. And what is common to both? 1, 2, 3. So that is equal to A. A intersection A is A, but phi intersection A, common elements between phi and A. A has 5 elements, but phi has no element. So what is common? A has 5 elements plus no element. So no element is common in phi and A, and answer is phi. All right, guys. Now fifth law. This is idempotent law. Idempotent law. All right, guys. Then the last one, A intersection B intersection C. One I have proven this is equal to A intersection B intersection C. But then can I include union in this? Oh, yes. This is equal to A intersection B union what? A intersection C. So what is that? This is which property? This is distributive property, right? This is distributive property. Okay. So now you talk about distributive property, you could say that your intersection is distributive over union. So understanding all this meaning would be taken much in details tomorrow. Wish you all the best. Very important. This one way in which brain behaves. Whatever you have learned, suppose you have enjoyed, make sure you revise that definitely in 4 hours, and then one more revision in the next 24 hours. You'll see, students, you'll never forget that. Once again, you'll learn something, make sure you see the video, see the concepts, 4 hours, then once more 24 hours. You'll never forget this. This is one trait of brain. It also has some disadvantages and advantages. I wish you all the best. If you like the video, students, do share with your friends. Have a nice time.